All right, let's pick up where we left off. So we had upgraded the environment to also have an enclosing environment, and then we updated our get and assign functions to check the enclosing environment if they had to. And now we have to update the syntax to also support scoping. So it should look something like this. And I guess we need to go to the parser and look. So what we're doing right now is we simply have a declaration, and a declaration can be a variable declaration, or it can be a statement. And I guess this is where we will implement this stuff. So we have a print statement, we have an expression statement, but now we also need a block statement. And this is interesting. A block statement is going to be a list of statements. So which doesn't really work with the fact that we return a statement from all of this. Perhaps we can just make an extra statement type. Yeah, so what I'm going to do now is to return a block statement, which will have, I'll define a block statement, and it will have a statements field, and the statements field will be, it should be a vector of statements. This will not work. Let's see, so a couple of errors. Okay, so interesting. I thought it would complain that we haven't boxed the statement, but it didn't. Anyway, let's go to the interpreter, and then we need to implement what we do with a block statement. And I think for now we'll leave it like that. And there's also something in here. All right. Okay. That's it for the errors. Now let's try to start by getting the parser working. So the first thing we need is something equivalent to this, and guess we can do this. Sorry, left brace. So if the first token is a left brace, then we will just try to pass a block statement. And for a block statement, we need something like the statements, which should also be mutable. And do we have this check function? We don't have that. What did we use instead? Okay, I don't remember. I feel like we should have a check function, but maybe... let's see. We have the peak. So maybe I'll just implement this check. So what I want to do is just return, we look at the first token, we look at the type, and we check whether it's equal to the supply type. So, what did I just do? Okay, so now we can go back and we can say while not a right brace and we're not at the end, then because now we have to decide how we handle errors. So we can do this then. I think the first error we get will be reported, which is, I guess is fine. How's the consume? Okay. And we don't return statements, but rather we return a block of statements. So let's check that. We need to prefix it like this and also wrap it in OK. Great. So now we need to fix these things. So how do we interpret a block of statements? Well, probably we just call interpret on the statements like this. And did not like that. Okay. And then we also had something in here where we need to string it, and I think we can do something like this. So I want to take the statements and map them to strings, and then I want to join those by, let's say, a comma. And let's see if that compiles. Did not compile. Because it's not an iterator, so we have to probably call into iter. And then here we have to collect, probably. Collect. Or do I just say collect string? There's no join method. Okay, there's no join on string, so maybe this is already good enough. I would probably need another parentheses. And what went wrong here? Let's just try something real quick. And then I want something like string is the numbers into an iterator, and we map them. We say to string, and we collect a string. What is this then? And then call exit something. Okay, bunch of warnings, and then, okay, so just saying that we collect it as a string is enough to turn into a string. It's pretty nice. And we were actually in here. Okay, so now we should more or less have it implemented to execute a block. Right, so actually I was a little bit too quick. Okay. So we need a new environment. And the enclosing environment has to be box, I guess, from my own environment. And then they have this try finally block. So let's do actually, maybe we don't even need this try finally. We can just say like block result is this. So first we need to say self.environment is the new environment. And before we do that, we have to say like old environment. And then we do this, and then we restore the old environment. And we return the block result. And, or maybe we just do this. Let's see if that works. Okay. Is an option of a box, so wrap it in some. Cannot assign to new environment. This new environment is not marked as mutable. Right. Okay. I wonder if there's a difference between from and new. Not really. So this is interesting. I just want to borrow this environment for a little bit. What if I just hold a reference? And then we go to environment and we say, this is actually a reference. And then we need a lifetime. Okay, so I am a little bit worried that this means we'll have to use something like a reference counted thing, because if we go into the interpreter, then we need maybe it's just wrong to say that we need a box. Really, we need a reference, but then we need a lifetime. Let's try to get this to work instead. And let's do this. Okay. Now the problem is, of course, that we'll need also lifetimes in here. It's like you write one lifetime and then you have to write 10. Oops. So how do we write this? Once a lifetime here. So it wants one both. So the reference lives the same as this guy. Okay. And then we need to fix this thing. Let's see if we can get this to work. Oops. Okay. Oh, what am I looking at? Interpreter, line 20. Mutable borrow. Okay. It's kind of interesting that these blocks interfere with this one, because they will never overlap. But I guess the problem is I'm saying that this has a lifetime. It has the lifetime that's the same as the lifetime of this one, which is the same as the lifetime of the environment itself. So it's thinking that this reference will live for the entire lifetime of the function of the interpreter. So what if we do this? Maybe this is completely wrong. Is it like that? But how do we do that? Because now I have to supply an extra lifetime here. Oh my god. Okay, maybe this, shouldn't really work, right? Yeah, still these are now considered overlapping borrows, which is not okay. So we can clone the environment, but that's like completely crazy. Okay, let's go back to the environment, remove these horrible lifetimes. We box this one again. Let's check that it more or less compiles. Okay, now it more or less compiles. So we would have to do this, and if we pretended that this compiled. Okay, now let's say it doesn't have an environment, but rather it has this reference counted pointer to an environment. And then we have to say RC new. There we go. And because we're not making a this would work if we're making a new interpreter, because then we could clone the reference counter pointer, but we are trying to make a new environment. So maybe we don't need this. Let me think about this. Okay, after some battling, I think I got it to work. I did get it to work, but is it the best solution? I don't know. So now the interpreter has a reference counter pointer to the environment, and now when we call evaluate, we have to do this gymnastics here where we get a mutable reference to the environment, and that can fail if you have multiple mutable. So this is checking the borrow rules at runtime instead of at compile time. So getting a mutable reference can fail if there's another place where the mutable reference is alive. But so what it will do is it will return none, or it will return some. This get mute returns an option. So we know that I mean, we could return an error here, I guess. Let's do that another time. We know that this mutable reference will never compete with anything else. So therefore it should be okay to unwrap it like this, and we just give a nice error message if it fails. And it's the same here and the same here in the variable. And then in the block statement we can create a new environment. We can give, so we clone the RC pointer and give that to the new environment. And then we make a clone to the old environment. So we have yet another pointer. Then we reassign the environment to this new environment. We interpret the results using that new environment. And then we restore the environment. And then we unwrap the results. So actually that's kind of what's happening here anyway, because Java has garbage collection, automatic garbage collection. So these are kind of like already reference counted pointers. So it's just a little bit more annoying here. Could mean that we need to structure it another way, but that is for another time. So I also needed to make this a reference counted pointer to an environment, and that meant that we had some changes here in the assign, where we again have to do this trick where we get a mutable pointer. I also had to clone it because otherwise the compiler complained. But we can now run it. So we can do things like this. We can print it, and then we can define a block where we say we define B, and then we can print A plus B. And now if we print B, it should fail exactly. So now we have scoping with local environments that seem to work, and that's it for this time.